Hello, this is Mr. Bryce, and I just want to do a really quick example of a chi-squared test, goodness of fit chi-squared test. So the idea is this is a different kind of hypothesis test where instead of doing a hypothesis about the mean or about proportion, we're doing it about a distribution. So it's a little bit like doing a hypothesis test for several different proportions at once. So here's an example of where we might see something like that. We've got a trading card company, and they claim that their boxes of baseball cards contain 70% veteran cards, 25% rookie cards, and 5% all-star cards. So we buy 100 cards in the box, and this is how many of each kind of card we get. And so what we want to do, since that does seem a little bit low, right, I expect more of these. So does that fit with what they say? I mean, in other words, like any hypothesis test, is the probability of getting a sample like the one we got unusual enough to suggest that, well, maybe their claim is off? So since this is a goodness of fit test, our null and alternative hypotheses are always just going to have to do with the distribution. And the null hypothesis is no change. So the distribution is what they thought. So that the probability of a veteran is 70%. The probability of getting a rookie is 25%. And the probability of getting an all-star is 5%. 0.5. All right, that's what we think the distribution is. That's what they tell us it is. And we're trying to see if this distribution is different. So we're looking for evidence that this distribution is not the same thing as what they said it is. And we're looking for alpha is 0.05. So what we're going to do is we're going to find the probability, assuming this distribution is actually the distribution, of getting a sample like the one that we just got. And if that probability is less than 5%, well, then that's unusual, and we're going to say, well, that's evidence that maybe it's not distributed like this. So what we need to do with this is we're going to use the chi-squared goodness of fit test on here, which is in stat tests, and then down at the bottom here, D is chi-squared goodness of fit test. To do this, we need to enter in data into here, because notice we've got kind of two sets of data. We've got what we think is going to be there and what really was there. So what we're going to compare is our expected counts and our actual counts. Now, our expected counts are, we bought 100 cards, right? Out of those 100 cards, assuming this distribution is true, how many of each of these different categories of cards should I expect to get? Well, for veterans, right, I got 100 cards, and 70% of them are supposed to be veterans, so I should expect about 70 veteran cards. For rookies, I'm buying 100 cards, and 25% of them are supposed to be rookie cards, so I should expect about 25 rookie cards. And finally, all-star cards. I'm buying 100 cards, and 5% of them are all-stars, so I should get about 5 all-stars. So these are our expected counts, and what we're going to do is compare them to our actual counts, where we got 80 veteran cards, 17 rookie cards, and 3 all-star cards. So where does this go? Well, where this goes is in L1 and L2 right here. So if I go to Stat Edit, what I want is my observed count to go in here. And then the expected count is going to go into L2. So L1 right here is going to be my actual counts. And all I'm going to do is keep track of which is which. So I'm just going to go vets, rookies, all-stars. So I had 80 vets, I had 80 vets. Oh, my numlock is off, that's why. I had 80 vets. We had 17 rookies. And we had 3 all-stars. We were supposed to get, or we could have expected to get, 70 veterans, 25 rookies, and 5 all-stars. So the test we're running is basically comparing the actual results we got with what they're supposed to be. Well, now we need to find the probability of, if it's supposed to be this distribution, what's the probability of getting a sample like this? And that is our goodness of fit test. So going over to calc tests, chi-squared goodness of fit test. Our observed is in L1. Remember, we put our observed values in L1. Our expected was in L2. This DF is our degrees of freedom, which is always going to be the number of categories minus 1. So here we've got 3 different categories. We've got vets, rookies, and all-stars. So 3 minus 1 is 2. So I have 2 degrees of freedom. And you can use calculate, but I like to do draw. So there is our distribution. And notice it doesn't look a lot like a lot of the other distributions. It's kind of way skewed in one way. And our probability, which is what we care about, is 0.091. So this P is 0.091. So now we can analyze this here. Our alpha was 0.05. That's our cutoff for being unusual. And compared to that, P is not unusual. It's not less than 0.05. So we are not rejecting H0. Which means our conclusion then is we're not rejecting H0, meaning we have not enough evidence that the distribution is different. So there is not enough evidence to suggest that the distribution of cards is different than claimed. All right, so this is just, like I said, a variation of kind of what we've been doing, a hypothesis test. Just now it's a hypothesis test for a different thing. It's a hypothesis test about a distribution.